Good day, everybody. Now we are going to look at extra credit question number 8, which reads, a business owner is in the process of deciding whether or not to invest in a new factory that refines oil to meet the high demand for that commodity. A test score showed that the old factory refines oil at a mean rate of 3.1 liter per second and a standard deviation of 1.0 using a sample size of 40. The new factory was measured to refine oil at a mean rate of 3.8 liter per second at a standard deviation of 1.5 using the sample size of 36. And the question asks, determine if there is any major difference at a 10% significance level. So as always, please pause the video and try to approach this on your own. I will also pause the video and we'll be back in about between 10 and 20 seconds. And we'll take a look at this together. Please try this on your own though. First. Okay. Hopefully you're able to approach this on your own. If not, I'll be happy to share how I approach this problem. So, as always, let's start off with the given information. We know that the information that we are shared so far is the old factory has a sample size or N1 of 40. The new factory has a sample size of N2, which happens to be 36, and the significance level or alpha is 10% or 0.10. So, to determine if there is a significant difference between the refining rates of the old and new factories, we need to perform the classical hypothesis test. So, in order to do that, as always, we can start off with stating the null and alternate or alternative hypotheses. So here, the null hypothesis or H0 should be there is no significant difference between the mean refining rates of the old and new factories. And to contradict that, the alternative hypothesis or HA says there is a significant difference between the mean refining rates of the old and new factories. So to summarize, the null hypothesis is saying no, there is no significant difference, and the alternative hypothesis disagrees with the null hypothesis, and it says yes, there is a significant difference. So let's test both of them out and see when we run this with statistics and the parameters that we know from statistics, which one is true. So as always, we are going to start our calculations by calculating the test score or the t-score. And here for this question, the test statistic is going to be calculated using the formula that I have shared on the screen. T equals, in numerator, we should have x bar 1 minus x bar 2 within parentheses, divided by, in denominator, this whole value, we have to take the square root of that. So square root of within parentheses, and within the parentheses we have two other parentheses. So the first parenthesis should be S1 square or standard deviation square for value 1 divided by N1 and close parenthesis for the first one within the big parenthesis or big brackets. And we have to add the second value which is within parenthesis, and that's S2, which is standard deviation value 2 square divided by N2, which is the sample size of N2. And we close the parenthesis and then we close the brackets. And I have shared the formula on the screen in order to eliminate any confusion, because handwritten work sometimes may not show this properly. So if you follow this, hopefully you'll be able to solve it just like I was able to. So Next step, we will do plugging and chugging as always. So when we plug in the values, we get t equals, in numerator within parenthesis 3.1 minus 3.8, and in denominator we take the square root of, within brackets within first parenthesis, 1.0 square divided by 40 close parenthesis plus open parenthesis for the second parenthesis 1.5 square divided by 36, which is the sample size, close parenthesis and close bracket. So I have shared my notes and my work and how I will have set it up on the slide. Hopefully you're able to follow this, and you can handwrite or use a calculator to check my work. So in numerator, if you subtract 3.1, or actually 3.8 from 3.1, you would have negative 0.7. And if you take the square root of the values for the first parenthesis, it should simplify down to 0.025, and for the second bracket or second parenthesis, sorry, it should boil down to, or it should give you the value of 0.0625, and we'll have to add that in the next step, which I have done, which is within the brackets. So in our next step, we take 0.07 and we divide that by square root of 0.0875, and the final value that we should get should be negative 2.37. So our next step after this is to find the p value, p is in Peter, and we can use a t distribution table or calculator for a two-tailed test, which is what we'll be using since we have two samples here. And the p-value for a two-tailed test with 74 degrees of freedom, which is n1 plus n2 minus 2, and t-score of negative 2.37 is going to be approximately 0.0205. And ultimately, for our final step, we will compare the p-value to the significance level or the value of alpha. Since the p-value was calculated to be 0.0205 and the alpha value is 0.10, we can see that the p-value is less than the significance level or the value of alpha. We have enough evidence to reject the null hypothesis, and that should give us what we need. And for our final answer, we can conclude by saying that at 10% significance level, there is a significant difference between the mean refining rates of the old and the new factories. I hope you were able to learn something from this question, and I hope that my setup was helpful. Thank you so much for reviewing all of my extra credit videos today. I know my format is a little bit different compared to some of my classmates. I tried the handwritten work, but when I was showing that on the camera, I just could not find a good resolution. So I figured that instead of handwriting everything, I would present this electronically, and I hope that you are able to view the numbers and my setup properly and follow along, and you learn something using these 8 extra credit questions that I have spent a significant amount of time preparing and presenting for you. I hope you learned something. Thank you so much once again for reviewing the video and viewing my work. I hope you have a great day ahead, and thank you once again.